Did the sun just break our GPS? What happened? Greetings, space enthusiasts, and welcome back to the channel. Today, we're diving into something that literally shook our planet. Not with an earthquake, but with a colossal solar event. We're talking about the recent powerful G4 geomagnetic storm that temporarily disrupted satellites and GPS worldwide in late May and early June of 2025. This wasn't just a pretty light show in the sky. It was a potent reminder of our planet's cosmic connection and vulnerability. So, what exactly happened, you may ask? On the evening of May 30th, 2025, our sun let out a massive burp, a powerful coronal mass ejection. Imagine billions of tons of superheated plasma and magnetic field launching off the sun's surface, hurtling through space at incredible speeds. The National Oceanic and Atmospheric Administration, specifically their Space Weather Prediction Center, quickly upgraded their geomagnetic storm forecast to G4, which means severe, just one step below the highest level, G5. Now, the good news is that the center of this coronal mass ejection was projected to pass just north of Earth. But even a glancing blow from something this immense can have significant effects. And significant they were. The Space Weather Prediction Center warned us about everything from GPS and GNSS disruptions to voltage control problems in power grids, satellite anomalies, and even high-frequency radio blackouts. This wasn't some distant cosmic phenomenon. It was coming for our tech. The coronal mass ejection arrived much earlier than expected, hitting us around 12:30 a.m. Central Daylight Time on June 1st. And boy, did it hit. The storm quickly ramped up to G4 levels overnight, delivering on those predictions. One of the most visible and stunning effects for many was the incredible aurora displays. People as far south as California and New Mexico reported seeing the northern lights, a rare and breathtaking sight for those latitudes. Though, I heard some unlucky folks had their views hampered by wildfire smoke and clouds. Cosmic timing, am I right? But beyond the beautiful light show, the real impact was felt by our technology. The primary impact zone was poleward of 45 degrees geomagnetic latitude, meaning higher latitudes were most affected. Think about it. Our modern world is incredibly reliant on satellites. GPS, for example, uses signals from satellites to pinpoint your location. During a severe geomagnetic storm, the Earth's ionosphere gets agitated, causing these signals to become distorted, delayed, or even completely lost. Imagine trying to navigate in an unfamiliar city or needing precise timing for critical infrastructure, and suddenly your GPS goes haywire. That's what many experienced. Delivery services, ride-sharing apps, even farming equipment relying on precision GPS, all potentially impacted. It highlights just how deeply integrated this technology is into our daily lives, often without us even realizing it until it's gone. But this wasn't just GPS satellites themselves were in the firing line. Geomagnetic storms can cause satellites to experience increased drag in low Earth orbit. Essentially, the expanded atmosphere due to the solar energy creates more friction, slowing them down. This means they need more fuel to maintain their orbits, shortening their operational lifespan. There were also warnings of satellite anomalies, phantom commands, electrical discharges, or even temporary malfunctions due to the surge of energetic particles. These aren't just minor inconveniences. They could be incredibly costly for satellite operators and the services we rely on. Think about the thousands of satellites orbiting our planet right now, providing everything from internet connectivity to weather forecasting. Each one is a complex, multi-million-dollar piece of equipment, vulnerable to these cosmic events. We also saw on our 2 radio blackout and an M8 class solar flare as part of this event. What does that mean? An R2 radio blackout signifies a moderate disruption to high frequency HF radio communications, primarily on the sunlit side of Earth. These are the kinds of radio waves used for long-distance communication, like by aviation or military operations, and even amateur radio enthusiasts. For pilots relying on HF radio for oceanic flights or ships at sea, such blackouts can be critical, requiring alternative communication methods or rerouting. And an M8 class solar flare is a significant burst of X-rays from the sun, causing additional atmospheric disturbances and further impacting radio signals. It's like a massive burst of electromagnetic interference coming straight from our star. Now, for those of you who might remember, the Space Weather Prediction Center was quick to note that while severe, this storm was unlikely to reach the intensity of the G5 storm we saw in May 2024. That was a truly historic event with even more widespread impacts. Still, a G4 is nothing to scoff at. It highlights our growing reliance on space-based technology and the very real threat that space weather poses to our modern way of life. So, what exactly do these G levels mean? The NOAA G scale categorizes geomagnetic storms from G1, minor, to G5, extreme. It helps us understand the potential severity and impact on Earth. A, G1, minor, can cause weak power grid fluctuations and affect migratory animals. Auroras are visible at high latitudes. Think of it as a gentle ripple in the pond. B, G2, moderate, can cause voltage alarms in power systems and damage to transformers. HF radio propagation can fade at higher latitudes, a bit more noticeable, like a stronger ripple. C, G3, strong, can require voltage corrections in power systems, and some power protection systems may trip. Intermittent satellite navigation problems, and HF radio degradation. Now we're talking about significant waves. D, G4, severe, our recent event, can cause voltage control problems, satellite anomalies, significant GPS degradation or outages, and HF radio blackouts. This is a storm that demands attention and can have noticeable effects on infrastructure and services. E, G5, extreme, can cause widespread power system collapses, extensive satellite outages, and complete HF radio blackouts for days. This is the big one, a tsunami of space weather that has the potential for truly catastrophic global impacts. While the storm activity weakened to G1, G2 levels by June 3rd, the Space Weather Prediction Center wisely advised everyone to monitor updates throughout the next few days. This recent event serves as a crucial reminder that while we're constantly pushing the boundaries of technological advancement, we're still fundamentally linked to the powerful forces of our universe, especially our own star. The sun, our life giver, can also be a source of significant disruption. Understanding space weather and its potential impacts is more important than ever. From improving our forecasting models to building more resilient infrastructure, we're learning to adapt. Scientists are constantly monitoring the sun, using advanced satellites and ground-based observatories to detect solar flares and CMEs as early as possible. This early warning system gives critical time for power grid operators to take preventative measures, for airlines to adjust flight paths, and for satellite operators to put their assets into safe mode. And hey, maybe it's not a bad idea to have a good old-fashioned map and compass handy, just in case. Or at least download offline maps to your phone. This G-force storm, while disruptive, also serves as a valuable learning experience, helping us refine our responses and build a more resilient society in the face of these incredible natural phenomena. It's a testament to both the power of nature and our ingenuity in trying to understand and mitigate its effects. Did you experience any GPS issues during the storm? Or were you lucky enough to catch a glimpse of the auroras? Let us know in the comments below. Don't forget to like this video, share it with your friends, and subscribe for more fascinating insights into space and science. See you next time, and keep looking up.